Hi everyone. You should be, if you're watching these straight through, you should have seen enough now to work through some of the part 1 homework for 2.2. I'm going to start now on examples that'll help you with some of the tricky things that show up in part 2 of that homework. Okay, so this is a great example, and I absolutely love these, but they can get a little messy, so we want to be careful. I have some stuff showing from the last problem, so I think I'm going to go in and change colors for now. Okay, so I look at this, and everything's trig, so there's not really a priority on who should be U and who should be dV. But I do see a product. It doesn't look anything like a product that would come from a chain rule. So I'm going to go ahead and try choosing a U. And it really doesn't matter. So I'm going to go ahead and choose the slightly more complicated one, since derivatives are still a little easier for most of us than integrals. So the derivative of sine 3x is going to be cosine 3x times 3 from the chain rule. And then dV would have to be sine x dx, which means V is an opposite of cosine. Okay, so right now, I know that the integral of sine x sine 3x dx is equal to U times V, so a negative cosine x sine 3x minus the integral of V du. So there's an extra minus, which will make that a plus. And I'm going to go ahead and move the 3 out in front. And now I have a cosine x cosine 3x dx. Okay, so first thing I notice is this doesn't seem particularly helpful. It doesn't seem harder to find the integral of cosine x times cosine 3x than it did for sine x sine 3x, but it certainly doesn't seem easier either. So right now I'm not very impressed, and this seems like a wash. But I would like to try it again. So here I'm going to switch colors so that we can keep track of what's happening with which one. So I'm going to go ahead and say, okay, well, let's keep the more complicated one as our U. Cosine, so it's a minus sign, and there's going to be an extra 3 from the chain rule. So derivative of cosine 3x is minus sine 3x times the 3 from the chain rule. dV is going to have to be my cosine x, which means V is my sine x, and there's a dx down here. Okay, so there's a second by parts. So let's see what we have. We have the integral of sine x sine 3x dx is equal to negative cosine x sine 3x plus 3 times, and then we get our next by parts. So U times V is sine x cosine 3x minus the integral of V du. Okay, so I see there's going to be another minus, and there's going to be a 3, and then it's sine x sine 3x dx. And I'm just going to guess that you're probably still not very impressed. But this is actually really neat what just happened. We started with the integral of sine x sine 3x dx, and we got back to it, which might seem like we've wasted our time, but we haven't, because all of this stuff is extra information about the antiderivative. So integration by parts is spitting out pieces of the antiderivative that we're looking for. Okay, so I'm going to clean this up just a little, get rid of the brackets, and then I'll talk about what we have to do to actually make use of this. So I have my sine x sine 3x, and I have my negative cosine, opposite cosine x sine 3x, and then I have a 3 sine x cosine 3x. And distributing in, that's going to be a plus 9 times the integral of sine x sine 3x dx. Okay, a little cramped, but we fit it. So here's what I want you to really pay attention to. we have written an equation, right? There's an equal sign in the middle, and we're interested in finding this integral. And what we've just found out is this integral is equal to stuff plus 9 times itself. This is an equation, we've done it before, this is an equation that we can solve for the integral we're interested in. So we're going to take advantage of the equal sign, and we're going to subtract this mess from both sides. I don't have to see this step, but I just want to make sure everybody catches what happens here. So if I have 1 times the integral, and I subtract off 9 times the integral, I'm going to end up with negative 8 times the integral of sine x sine 3x dx. And I know that that should equal negative cosine x sine 3x plus 3 sine x cosine 3x. And then all I have left to do to solve for the integral I was looking for is divide everything by negative 8. So I'm going to get, I can quit selecting things, sine x sine 3x equals, okay, so dividing by negative 8, so this is going to become positive 1/8 cosine x sine 3x. And then divide this by negative 8, and we get negative 3/8 sine x cosine 3x. And we don't want to forget our plus c. Somewhere along the way from all that integration by parts, we did integrate, and a plus c should have shown up. I'm okay if it doesn't show up till the end, but don't forget about it. So this is our answer. And again, you can check it. It's a little messy, but it really should work out for you. So I love this trick, and this should work basically anytime you're working on these kind of cyclical functions that end up getting back to the same thing that they were when you take enough derivatives. So product of 2 different sines, 2 different cosines, a sine and a cosine, an exponential and a sine or a cosine, any of those things, this is a decent trick for. Anytime you could take the derivative twice and get back where you started. You want to be careful, because if you can get back to where you started in one step, a lot of times you kind of lose everything, so that's not really what we're looking for. We're looking for 2 steps. I want to, here, let me snake a color, point out one other thing as well. This right here, it was really important in that step that we stuck with the same part for u. So I started with the sine of 3x, and on the second step I could have, instead of choosing the cosine 3x, I could have chosen the cosine x, but that would be bad. So alternative number 2, let me show you. If I had accidentally said u equals cosine x, so du equals opposite of sine x dx, and dv then would equal cosine 3x dx, which means v is 1/3 sine 3x. Okay, so this looks fine so far, but here's what happens when we move down to this step right here. This is after number 2. The negative cosine x, this is the same. But in the parentheses, we would have u times v, so we would have 1/3 cosine x sine 3x minus the integral of v du, so that's going to be a plus because of the du being negative. I'm going to use the 1/3 out in front, and then I'll have a sine x sine 3x dx. And this is all inside the brackets, so we'll still have to multiply it by 3. So notice in the next step, this again would stay the same, that was fine. When I multiplied the 3 by the 1/3, I would just get cosine x sine 3x, and then I multiply the 3 in here, and I would end up with a 1. I wish this would stop selecting things. Okay, I end up with a 1. Where was I? Right here. 3 times 1/3. Okay, so I end up with a 1 times the integral of sine x sine 3x. Okay, so now if we pay attention, when we go to add this up, the negative cosine x sine 3x and the positive cosine x sine 3x are just going to drop out completely. And what we will be left with is that integral of sine x sine 3x is equal to the integral of sine x sine 3x, which is absolutely true, but very unhelpful. So this is really important. You need to realize that integration by parts is its own inverse process, basically. So not like derivatives, integrals sort of thing, but if you do integration by parts and then you do it again without flip-flopping what you're using for u's and what you're using for dv's, you will always get back where you started. So be very careful. You want to not undo all your hard work. Okay, I think that's it for this long one. Thanks for watching.